Space motion sickness usually occurs within a few minutes or a few hours after entering weightlessness, and usually it's characterized by headaches or malaise, nausea, vomiting. 60 to 70% of astronauts face this. So if you're interested in being an astronaut, then you hope that you are not in the majority in this. It usually occurs in the first few days and then just disappears altogether because your body, your brain is used to it. That inner ear issue, it's usually an inner ear issue that's in conflict with what your eyes are perceiving. And you feel like you're falling, but nothing is falling around you. And that's where you have sort of this issue. And again, it occurs due to the vestibular or inner ear, so space motion sickness, because of the inner ear issues, along with the discrepancy between what the eyes see. So make sure you note that that is what's happening on that. Countermeasures for space motion sickness. Well, there's biofeedback training using virtual reality, water immersion, because when you're in the water, you can sort of simulate that microgravity. Medications are also used. And when I flew on the Vomit Comet, they gave us some medicine. I don't know if it was promethazine, but it was great. It really helped. So, and we were still cognizant enough to do our research and actually be able to enjoy it. At least I was able to enjoy the flight. One of the other flyers did not have the same experience. Hematologic and immunologic systems. In microgravity, there is a change in the shape of blood cells. They go from normal like this, where they're like that donut, they're kind of a pinched sphere, to a regular sphere. So please note that down. That is something that really can affect the blood cells. And usually, anemia is a characterization that happens usually somewhere around 4 days into spaceflight because it's a decrease in the number of red blood cells. After 3 months in space, there is a 15% decrease in red blood volume because, one, these are taking up a lot more space within your veins. So there's just a decrease in volume. Now, this does return to normal once you have Earth's gravitational forces. Activity of lymphocytes reduces, but this has not really caused a problem thus far. Again, if you have less lymph node activity. But the body seems to be able to function even though the blood cell changes. So it's just something to note that this is an issue. Now, for long-term spaceflight, maybe it's going to be a larger issue. So these are things that astronauts and biomedical engineers and doctors are studying right now. And effects of space radiation. This one is kind of wild. Astronauts are subject to more radiation than they're exposed to in Earth because we don't have the Earth's magnetic field kind of protecting from these things. So you have galactic cosmic radiation and solar particle radiation from the sun. So crew must monitor the radiation level with personal dosimeters that are detecting how much radiation they get. And some of the results of this are potential infertility when they return. So you need to make sure that you have all the kids that you want to have. Astronauts have been able to have children, as far as I know, after they return, but it can have potential effects there. Also, cancer. They're at higher risks of cancer later on in life and other diseases. And solar flares can be extremely dangerous, especially if you are on a spacewalk during a solar flare. So it's really important that that on Earth we monitor solar flares so that we don't do any spacewalks. And just a little note on that, during the Apollo program, these are interesting facts here. During the Apollo program, there were several near misses between astronauts walking on the surface of the moon and a deadly solar storm event. The Apollo 12 astronauts walked on the moon only a few short weeks after a major solar proton flare. Just weeks after, so it wasn't like minutes after, but it would have blasted them with radiation enough to pretty much kill them on sight. And the same thing halfway between Apollo 16 and 17, they would have had a deadly outcome if they would have gone outside their aircraft or their space shuttle to go play golf. That was when they were hitting golf balls around. Within minutes, that would have hit them actually on that one. And it would have killed them immediately. So a daily dosage. So something to note here. A daily dosage of space radiation is equal to 8 chest x-rays per day. That's the amount of radiation that they're getting. So getting one chest X-ray, and the doctor may freak you out. 1 day in space is 8 of those. So it is significant, and that's why they're at higher risk of cancer later on, and there can be potential infertility problems. So keep that in mind if you want to be an astronaut, at least with our current technology. Are we ready for Mars? There are still things that we have to try to figure out microgravity. NASA is in collaboration with research universities trying to figure out how can we make countermeasures for some of these to combat these things. That might be something that you work on in your career. Using zero-G airplane for testing countermeasures is one thing. So I got some pictures in here. Man, this is where we were. You saw some of the videos of that. These are a little bit fuzzy. Sorry about that. And so in the zero-G airplane environment, they test because you have this 18 to 24 second weightlessness per parabola. I do not know who that is. And there's about 30 to 40 parabolas per flight. When I flew, it was about, I think we got 25 parabolas. And what you're getting is from this point here to this point here, as it's going over the top, then you're getting that, it's kind of like the sense of being in an elevator that goes up and then it stops and you're like the stomach kind of goes up into your chest a little bit. Well, that's just like that permanently because they're matching that feeling as they curve up and go down, and that's where you get that weightless. So the pilots have to be incredibly good to be able to give you that sensation for that 18 to 24 second period of time. And our pilots were really, really good Air Force pilots. Water has some really cool properties in zero-G. If you want to pause this and read through these, feel free to do that. But really, what's going on is with surface tension, it's kind of adhering more to itself than anything else around it. And when it's on your skin, it kind of adheres to your skin and sort of pools up. So there's some pretty cool videos about water in space if you want to check some of those out. And that is it. It is time to sleep in space.